Assalamualaikum warahmatullahi wabarakatuh and good afternoon to everyone. We are from Group 1. We'll do summarize for a topic, a good practice guide to energy monitoring and integrity. So my name is Ahmad Amirul Afiq bin Fauzzi. My other friend is Mohamad Izwan bin Othman and Mohamad zulqarnain bin muthaza. So the introduction for this is EAI, measuring how much energy is spent and where it is consumed, is the first step in effective energy management. To understand the potential for energy performance improvement, data on energy usage must be gathered and analyzed. Targets for energy consumption can then be set and actual energy consumption can be measured against the target. Monitoring and targeting have great promise for reducing energy use without requiring capital expenditure throughout the world. So, next we move to what is monitoring and targeting. A method of energy management that relies on data from energy use and other sources to remove waste, decrease and regulate energy usage, and enhance operational process. So, at a factory level, the steps are: first, identify where energy is consumed within the factory. Second, record energy consumption at site level and at the major consumer. Third, analyze the data in order to highlight consumption trend. Fourth, develop energy consumption baselines that represent typical. Fifth, set target for energy consumption with reference to the baseline. Six, monitor consumption versus the targets to identify when and why it is different. Okay, why monitoring and targeting? So the first reason is cost. Energy cost saving typically about 5 until 15%. And then waste avoidance. Not just energy, also water and materials can be saved. And then capital investment. Improve data for justifying capital investment. So the last reason is budgeting. Improve budgeting due to better prediction of future energy consumption. How to conduct monitoring and targeting. So this consists of 6 steps. So the first one is data collection, next data analysis, monitoring frequency, targeting, reporting, and revising energy performance indicator. Okay, so we go to the first step, which is data collection. Energy sources at site level, which means energy consumption data should be collected for all significant energy sources at site level, such as electricity, thermal fuels, transport fuel. And then next, energy consumer on site. Significant energy user on site such as boilers, furnace, steam generators, dryers, and major processors should be have data collected. And lastly, an organization. When an organization starts implementing monitoring and targeting, they are unlikely to have the data required to develop a comprehensive system. The second step is data analysis. So in data analysis, there are several techniques for analyzing energy consumption data. So the first one is monitoring the thermodynamic efficiency of specific plant. The effective way of monitoring energy consumption for specific equipment such as boilers, refrigeration equipment and CHP plant. Next, the conversion efficiency ratio is calculated by comparing energy output to energy intake, and it is then compared to prior performance design efficiency of both. Then, the next technique is comparing current energy consumption to previous energy consumption. So, this is data analysis at its most basic. It tells us whether energy consumption is rising or falling. So, this is the diagram of basic data analysis. The same data that can be accumulated over time which can show longer term trends and can remove seasonal effects such as weather. It shows a clear upward trend in energy consumption, although it does not indicate why the trend is upward. So we move to the next technique, which is monitoring specific energy consumption. So specific energy consumption generally measured as energy consumption per unit of output. So the second point is it can be useful for benchmarking against other companies producing in a similar environment. It is generally an indicator of energy intensity. As specific energy consumption rise, the energy consumed per unit of output is rising and vice versa. When calculating specific data consumption, so this is the calculation of uh, specific energy consumption. So specific energy consumption equal to energy consumption over output. As output increase, the first term in the equation, base load over output, false, whereas the second term's variable over output remain constant. This is the diagram of specific energy consumption of an electric arc furnace. It shows a downward trend as output increase. Specific energy consumption is an imperfect indicator of energy performance. Other indicators are necessary to evaluate whether the energy management action being adopted in an organization are producing improvement in energy performance.
My name is Mohamad Zulqarnain, and I will continue with monitoring energy consumption against a baseline using regression analysis. We use regression analysis to solve the problem of high specific energy consumption in process with a large renewable. The normal relationship between energy consumption and the variable that drive energy consumption also as a driver. In industry, the main driver is often output. We use this analysis to determine the normal relationship between energy consumption and output. It can tell us of the normal or expected energy that given a level of output. We also can compare the actual energy consumption with the normal energy consumption. If the is a have compare with their normal energy and actual energy consumption, it will be indicated good energy performance. Next. Okay, this one is the uh, regression analysis of electric art for that the tech data same as used to plot monthly energy consumption versus output in the scatter diagram with a line of the best fit draw to the data using regression analysis. So in the former, the yellow dot is a point with the high specific energy consumption, which look like a poor energy performance. The same yellow, the same yellow is the same yellow in this scatter plot is a normal, normal or good energy performance. Okay, next. You can also see at the scatter plot, the slope reflect the energy spent per unit of output. Meanwhile, the intercept represents energy consumption as output reach zero. The R square parameter shown under the equation is the regression coefficient and is an indicator of the distance between the point in the graph and the line of the base. A high R square indicates that the line of the fit is close to the point. We can also say the baseline equation is produced using regression analysis. We use the standard equation to as we used to get guideline. Okay, for for monthly base load is 4,444,764 kilowatt with variable consumption increased by 571 kilowatt for each additional unit of output. So can have a good connection in this baseline equation representing normal energy use because the R square value is 0.94 is below of 1. So it's good for our energy consumption. Next, we go through with monitoring energy consumption against a baseline using multivariate regression analysis. As we know, the energy use often influenced by the number of factors. The If that the case, multivariate equation can be used to create a baseline equation that describe the relation between energy use and the driver. So as we see the equation is the equation y equal to M1 x1 plus M2 x2 plus C. So gas we can apply it as gas consumption equal to coefficient 1 plus throughput plus coefficient 2 time average external temperature plus constant. Is as is look like the to be look like a bakery that use gas for space heating and to heat the oven that bake the bread. It also likely to be caused by the average air temperature. So it's like the oven. As we know, when when we open the oven, the heating in oven will be out. So they have losses in heating. Okay, next. This is table, example table for 8-month baseline data for bakery. Heating degree day is measure of how far the average external temperature for the month was below the temperature level normally recommended for turning the space heating. As we know, we on in this oven we need to actual heating temperature to make sure the condition of their baker or break is good. Okay, next. So we started example is 15.5 Celsius if a average temperature for 30 day was 10.5 degree. So heating degree day 30th day time 15.5 minus 10.5 equal to 150 HDD. HDD we call now is heating degree day. Okay, next I will cover about Excel regression function result. We can see the data by using the Excel software Microsoft Excel by just simple calculate by using the equation. So as we know, the R square is 0.938, but we round off is 0.94. So it will get the same value as the before I said. So as we can see, the p-value is measure of the likelihood that there is a relationship between energy consumption and the two driver. This p-value is two driver of all we call it production and heating degrees day. If p-value is low, below 0.05, then it's very likely there is a relationship. In the case can we lost the energy consumption is or we call it is bad condition. Okay, next. Okay, control chart. Control chart the difference between actual consumption and baseline consumption. It can be plotted in the control chart with upper and lower limit set to reflect normal variation in energy consumption. It's a, if it divide below the lower limit, it is again abnormal and should provoke an investigation into the cost improve performance and it see if the circuitous which cause it can be repeated and standardized as normal practice. Next. Okay, for to see this but control chart example, we can see the lower lower cost atau although its use can see the highest consumption on March to April until almost reach 100,000 before, and you can see the green line is the upper control unit. It can also say the normal consumption or good performance energy, but on this September until November December is the bad performance energy. Next, CUSUM charting. CUSUM charting, also we call cumulative sum control chart, is a full technique for illustrate energy performance of plant or energy consumption system. We can monitor and compare weekly or monthly. The CUSUM is cumulative sum of difference between the actual consumption and the baseline. So we use CUSUM charting is to monitor easily by monthly or weekly to to get good performance. Next, okay. This is an example for a CUSUM. So we can see the data from January until December, and the output of a month or each month, and the baseline energy consumption is the what uh, energy is out for this month, and actual is what we need to what we uh, expect the month consumption, and the actual consumption baseline consumption is the what we get actual from actual energy and output. So the CUSUM for kW hour is the data from before 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 we start the factory until the first month of factory. That's all for me, and I will pass to my friend to continue this slide.
My name is Mohamad Izwan, and I will continue the presentation with monitoring frequency and targeting. Monitoring should be done frequently because it is an important aspect. As we monitor infrequent, the energy may continue for an extended period without being corrected. It means we can handle the waste properly. Next, benefit by doing this is uh, the cause of waste are more easier to identify. The longer period when we monitor, the data may be disappear. Furthermore, it is recommended to monitor significant energy user at least weekly in order to prevent extended period of excessive consumption. Next is the target. Next is the targeting. Monitoring and targeting are so related. After monitoring process, the data and information can be used to set the target. There are 4 points to be considered to set a target. The first one is plus a percentage of thermodynamic. It is allowing. It is to allowing for imperfect process and for the percentage loading. Second, manufacturer recommendation. Third, a benchmark against companies carrying out similar activities. Last but not least, a percentage improvement versus the previous shift. Data collected are shown from the chart. For example, CUSUM chart can be used to identify sustainable period of good performance. Next, next is reporting. There are five formats that can indicate energy performance, which is absolute consumption, actual consumption versus budget or target, contour chart, heat map, and lastly, overspend Liga table with traffic light. For absolute consumption and contour chart, it's already explained by our teammate. So I will explain about the actual consumption vs budget or target, heat maps, and overspend Liga. Next, in this chart, in this chart, the data are collected from the different information between actual consumption and budget. This data also highlighted in the CUSUM chart. If we see the graph, there are some increasing ratio from January 6 until April 16. January 16 until April 16. But at the next month, the ratio show some decreasing in the chart and continue stable until December 16. Next, heat map is a colored represent of data where different value are represented as different color. As you can see, this chart use a special color gradient, which is blue, cayenne, green, yellow, and red. For color code, blue is a lowest energy consumption, and for red is the highest energy consumption. From the chart, we can see from 1 p.m. until 2 p.m. are colored with red. It means during that time energy consumption is very high, while 6 a.m. and 10 p.m. are the lowest energy consumption. Next, in overspend Liga table with traffic light, the red indicator consumption above control limit. Uh, Yellow indicates consumption within control limits, and green indicate consumption below the control limit. Next, there are many software to monitoring and targeting the benefit of use. There are many software and monitoring and targeting. The benefit of using software are helping to achieve more accurate target setting with a choice of advanced regression analysis formula, performance indicate, historical comparison, and load profiling. Exception report show waste where consumption exceed target, allowing to monitor the usage properly and effectively. A good software package when until utilized correctly may save a lot of time and hence be highly cost efficient. Next, lastly is the conclusion. From the overall presentation, we can conclude by applying energy monitoring and targeting, it can improve the exciting operation procedure, all data need to record in the table to make the management measure energy consumption. Next, with an understanding of energy usage data, process workload can be distributed for better performance. Lastly, if the organization strictly follow the and practice this system, we can reduce annual energy costs in various industrial sector between 5 and 15%. That's all from me. Thank you.